Section 5.4, question E55. What we have going on here in terms of the context is remediation. So this is actually a major problem. This is something I did my dissertation on, the percentage of people that have to take mathematics remediation and whether or not high school math courses prepare students well enough for college math placement. But I'm not sure these data are real. I think the actual percentages are quite a bit higher than this, especially for math. What's going on mathematically, though, is the law of independence, and here we have a slightly more complicated or involved example that uses multiple counts of the rule of independence. So we have a sample of 10 freshmen, and we know that 19% of college freshmen have to take a remedial course. What is the probability that all 10 will have to take a remedial course in reading? And we're assuming that the population is so big that we're not really worried about sampling with replacement. In other words, essentially we have an independent situation here, so that if our first person, well, let's go ahead and put this in. So the probability that the first one will have to take, probability that, let me just put remediation, for our first student would be 0.19. Okay, because we know that 19% of all people, so if we just sample random college freshman, it would be a 0.19 probability that that freshman does take a remedial course in reading. But that's not what we really want to know. We want to know probability that 10 take a course in remediation. So how would we do that? Let's just do it one by one. So the first person that we sample, we already know that that was 0.19. And now we go to the second person. The second person we sample, because the population is so large and we're not worried about whether or not we have replacement, it still has a 0.19. This first one that we chose is not going to affect our the probability that the second one will be in a remedial course, assuming that we're doing a random sample. So the probability of that one is also 0.19, and because they are independent, or we're treating them as independent, we can simply multiply the two together. We don't have to worry about the conditional probability. Then we look at the third person that we sampled. They would also have that 0.19, and by extended rule of multiplication here, we can just simply multiply it, not worry about any condition. Notice that we're going to keep doing that until the 10th person. Whoops, wow, that 10th person has a impossible probability there. Let's grab that eraser here. That was a really big eraser. So we have these dots, by the way, I'm putting up higher to represent that the multiplication continues. If they're listing or adding, we tend to do down on the ground. So here then, we have 10 of these copies of 0.19. In other words, it's 0.19 to the 10th power, and you don't need to compute that. They have a drop down, hopefully, so you were able to pick that. The probability that at least one will have to take a remedial course in reading. This is actually much more complicated than it sounds. So we might think, let me just start a new screen here. So probability at least one, let me put it as greater than or equal to 1 remedial. So you might start, well, let's get our remedial, 0.19, and then we'll take it times the non-remedial, because we only need one of those, and maybe another non-remedial. But we run into two problems here. First of all, we don't know how many students are in remedial. It could be 1, but it could also be 2, might be 3, could be all 10, and all of those would satisfy this condition right here. The second problem is we don't know that the first person did get remediation. Even if the first person we chose didn't get remediation, so this was a 0.81, we still could have had someone later on get the remediation. So there's two issues with that. Now we could use more advanced rules of probability and the combinations that we had used earlier in this course to solve this through a more extensive, elaborate method. But there's a really neat trick here. So the probability of greater than or equal to 1 remedial is the same as 1 minus the probability of no one being in remedial. In other words, since we know that probability of all the possibilities have to add up to 1, we're starting with 1 and just subtracting out the probability that none of the students were remedial. What does that leave us with? Well, the only other situations are where they at least had 1, potentially more, remedial students in the sample. So we're starting with kind of the universe, all of the possibilities, and then just subtracting out the one case where there are no remediation. And this is fairly easy to calculate because, in other words, we need everyone to be not remedial. Well, there's an 81% chance that any given student is not remedial. And so if we take 0.81 times 0.81 times 0.8, since again they're independent, we can do this, or we're assuming they're independent, we take 0.81 to the 10th. And that would give us the probability that none were in remediation. So the probability that at least one is in remediation is 1 minus 0.81 to the 10th. If you are typing this on a calculator, you'll want to do it one of two ways. Either do 1 minus and then make sure you get the parentheses in there so that you're not doing 1 minus 8.1 to the 10th power. That's what our answer was for part A. That's a totally different answer. Somehow you need to make sure that this 0.81 is getting raised to the 10th power. You could even put this in first, save that answer, and then take 1 minus that answer. That would be kind of a safe way if you weren't confident about using the parentheses. But this right here should give you 0.878, or of course your numbers are different.